Yeah, so we started running through collections, and then we did Boolean logic, started on that. So we're gonna go through that. So let's start number 3. I'm gonna mute myself here, and let's go. All right. So we're starting session number 3. We're going to go and complete our Boolean logic exercise, find out what's true in Python, and then we are going to drop off probably from here to conserve bandwidth. All right. And so we are going to look at uh, Python Boolean logic again, and then we're going to jump into the wonderful world of strings and go through that exercise. And that would potentially round up the exercise for today. I want to have a nice cutoff for the next session to work with. So let's take a look at what we're dealing with here. I'm going to clear the screen and jump over to our exercise area here. Let's go. All right. Yeah, I moved myself to the top in hopes that I'm not going to be blocking the view this time around, because we kind of we kept running into me in various spots. So today again, we're starting looking at Boolean logic. So it's going to be boolean underscore logic.py. Just to remind you that it is driven, the running of this particular file is driven in the file called replit. That's what commands this environment. This environment is repl.it. If you need help on understanding how to start this whole thing, you can type in help underscore boolean underscore logic on Twitch, or if you're watching it through the Python Learn Marathon website, you can see instructions on the site to see how to get there. So let's take a look back into the Boolean logic. We have gone last time through trying to understand what truthiness is in Python, right? The idea of truthiness is in order to be able to shorthand variety of checks within within if expressions, within any kind of Boolean expressions, we can simply ask whether we are able to pull, just quickly inquire whether a certain thing is true, as opposed to comparing it to anything. So if we take a look here, we did a quick check on truthiness of 0, 1, -1, 21, right? For integers, if we just do a quick run here, we're going to spit out everything here. So we got to go with integer truth. We got our false true, true, true. So -1, 1, and 21 are true. Then we looked at float truths. So that is for floating point. We did check for truthiness by converting them to Boolean. But you would see an if statement below. You don't genuinely convert anything to Boolean. You just say if that particular variable or that particular value, and the truthiness will be revealed in that request. But for floats, we looked at 0.0, 0.1, -1.1, all of those. The first one turned out to be false, the other turned out to be true. Then we looked at collections, and we looked at the inside workings of collections. We looked at if a collection is empty, this is where the false comes in. So this allows us to check and perform no action if collection that came back from some kind of request or got passed in is empty. So we check on that. Interestingly enough, is, as I mentioned before, it does not look at the content of the collection. So it doesn't matter if you have all kinds of falsy values inside of a collection. If collection is not empty, it's going to return true. So that's our second value here. And then we looked at empty set and empty dictionary, and with full dictionary, with empty tuple and full tuple, and we got the results as we would expect them. And kind of a quick look at using that in if statement. If statement is going to be something that's going to come in the next session to just kind of go over. We also looked at the non-value. Non-value comes back as false. That being said, there is a check for is none within the context of Python. So if you as you understand, you might get a variable that comes back with variety of results, right? Because we are dynamically typed, so we could have a variable that is either none or empty or equal to 0. And if we want to check specifically for whether it came back as none, we would actually do if this is nothing is none. So that would be the check for print this is empty. This is a non-value. And so that particular check, so well, nothing has a G at the end, so that misspelling does not result in anything. This is a non-value would be returned here. So we are specifically checking for this is none is equal to none. So this is how we would do that, checking for specifically non-value. Then we looked at empty string and a string with value. Empty string came back with false. A value in a string came back with true. And we also did a check for an undefined variable, so we cannot call upon an undefined variable in Python. It actually caused an exception, so that's why it's commented out here. And this is not a variable in locals, allows you to actually check whether a local list of local variables contains a variable by that name, which is it carries some value. It's not commonly essential, but it does have, Python does have that capability to verify what's happening. Let's take a look quickly at various comparisons, right, turning into Boolean values, as expected. So we're gonna print, your usual. So let's do this. Let's create a value test me equal 1, and we're gonna do test me less than 0, and sorry, let's just print comparison operators. So we're just going to compare various values using comparison operators. So we do print test me less than 0. We're gonna run test me equal to 0. We're gonna run it. It's gonna come back to false. If we do print test me is greater than, let's put a string variable 2, we are actually going to get a type error, right? So the comparison, you want to be doing comparisons against comparable types. So we can, so let's do the, this will throw a type error exception. So we commented this out, and then we are going to print test me is greater than 2, so we're, or 2.2, right? Or sure, let's do that. We're going to get another false, so we can compare that to Boolean. We can do print test me is equal to true. So let's take a look if integer 1 is equal to Boolean true. So it will actually align one to the other and will say that both those values are okay. Let's take a look at the next one over. So we did double equal. So I mean, the rest of them behave as you would expect them to behave. Test me not equal to 3 is gonna come back as true because it's 2. Let's see, so test me not equal to string. So in this case, because the types are different, interestingly enough, not equal is going to be okay, saying that one is not equal to the other, because it actually means something. So that's something to be cognizant about. And that's why kind of digging through this subject is somewhat interesting is because you could end up with some quirky discrepancies if you're not aware of this kind of expectation. So because we're looking at two different types here that we're comparing, Python will say that is true, they're not even close, they're not even in the same realm, so they are not equal. So you can proceed with that. So it's something that, like, if you're okay with that comparison, you can leverage, but if you're not okay, you could actually end up in a sticky situation here. So this will be true as the types are different. So that's kind of a quick run through. Less than equal to, greater than equal to, those obliged by the same as less than, greater than, or double equal to. So we don't necessarily have to dive into those per se. So let's take a look at the in operator. So in operator is an interesting beast, and it allows you to do all kinds of checks very rapidly. So one of the things, let's start with substring. So we haven't really looked at strings per se, but we can do a just a quick messing around with literals. So if we do, let's do print in operator examples, just so that we have a delineation. I don't know, I'm just kind of improvising on the fly something that would give us visual separation in here. And then let's go and do print sample in there is a sample some where in here, right? And so we're gonna run that. So what it does, it looks for a string in this larger string. And it's gonna tell us, yes, this substring exists in a string. So this is a very quick way to check whether a string is in another string. Print sample in there is nothing of interest here. Obviously is going to return false, right? Because sample is not in this string. Same thing goes for value in collections. So if we're going to do print 1 in 1, 2, 3, 4, 5, let's run that. It's going to come back with 1. If print 1 in 3, 4, 5, 6, 7, it's going to come back with false. So in is very nice in a sense that it lets you do that. Let me check something because I don't remember that off the top of my head. I don't think that will work. Print 1, 2. I think that will not allow us to do that. 1, 2, 3, 4, 5, 6. So that will come back with false, because what it would literally look for, it would literally look for 1, 2 as a whole thing. So what I'm going to do here, let's try this right now. It would literally look for that list. This will be a little bit confusing, but I'll do it anyways. YOLO, let's do it live. So we're gonna go again 1, 2, 3, 4, 5, 6. However, the crazy thing that I will do here is this. So what I'm doing is I'm putting list that contains 1, 2 inside the outer collection. Let's try this. Let's see if that finds it. So that's just broke everything. It is true. Okay, cool. So what we're looking at here now is we're looking at, do we have a value that is a list inside this inside the list, right? So list is, first member of the list is 1, 2, second member of the list is 3, then 4, then 5, then 6. And so we have found 1, 2 inside of this, but we cannot look for list and sublist, essentially, is what I'm going for. Don't know if this was helpful or more confusing, but let's continue. So there is a meaning for in as a query against a dictionary. So the cool thing with query against a dictionary, by default, it is looking for whether a particular key exists in a dictionary. So it's so let's do this print. Let's look for key of 1 in our dictionary. 1, 1, 2, 2, 3, 3, right? So we did, so we are creating a dictionary in line that is of key value 1, value 1, key value 2, or value 2 stored in there, key value 3, stored 3 in there, right? And so we're looking for whether key 1 exists in here. So if we run this, we can say that key 1 was found. Key 1, string literal, was found. Just to make a silly example, I'm going to just copy and paste that whole line, and I'm going to copy and paste, and I'm going to look for value 1, just to show you that it is looking for keys and not values. And then let's run that. So that's going to come back with false. So value 1 is not being looked for. So just to clarify what's going to play out here. So next, we are going to take a look at a little exercise. I actually want you folks to take a look at the little assignment on line 68. We're finally getting kind of enough things to play with to do a little Boolean logic assignment. So we are looking at a condition where a value is either none or it is outside of an interval right value inclusive, right? So we're kind of going through, back to our simpler days. So what I would like for you to do is to just take maybe a couple of minutes and try to put this logic together and put it in a print statement. And then, so let's create a sample 1 that is going to be none. Then sample 2 that is going to be let's pick an interval that's going to be outside of 5, 12, and then 12 is going to be inclusive. So there is I just realized that there's an important element that I haven't covered, and that's Boolean logic with ors and ands, right? So here we're looking at, all right, so let's take a look. Value 2 is going to be 7, and sample 3 is going to be 12, and sample 4 is going to be 14. Sample 4 is going to be 14. And so we need to put together a Boolean expression that tracks for that. So the way we can join Boolean expressions, so Python supports and or. However, it's a lowercase and or. So you can chain two statements with that. So let's do the following. Let's write a statement and then just go around sample 1, around sample 2, around sample 3, and then print in that order whether they are true for that example or false. Sorry, I thought I had a better setup for this one a little bit than what I did. So go. So I'm gonna do sample exercise. So I'm just copying the variables in here, and then we're gonna put expression around them, and see what it does. Sample 2. All right. So let's take a look at that. So the first one, so we're looking for an expression that is going to be checking whether sample 1 is either none or it is outside, right? So we're gonna check sample 1 is none, or sample 1 is less than or equal to 5. So we're looking at sample 1 is less than or equal to 5 or greater than 12, or greater than 12, right? So first one is true. Let's do, I shouldn't have copied that, so I'm just gonna take this line and check whether I did that correctly here. Sample 2. Or is outside. So that's not correct because we need to have an and here, right, for this condition. And this condition is going to need to be an and. It is, oh no, that can't be an and. Oh wow, I got stuck on my Boolean logic. What's happening? All right, it's been a long day. So we are looking at either none or is outside of an interval, right value inclusive. So it's either or sample is less than or equal to 5 or sample 1 is greater than 12. Okay, so we're fine here. So it's all ors here. Let's go 2. Let's go 2. So this one is false because it is between 5 and 12. And then we're gonna go with sample 3. So let's copy this and Control C, Control V is gonna be bane of my existence. Control C, Control V, and we are going to take a look at sample 3. And And again, let's do that. Our sample 3 is 12, so it is false because it is exactly equal. And then we're going to go with sample 4, and that one should be back to true. Okay. That's going to be back to true. Let's run this, and that is back to true. Okay, good. It's nothing like doubting yourself with basic Boolean logic. Excellent. So we have taken a quick look. I kind of jumped into this and or elements. However, we are able to chain with ands and ors, similar to how we can do in any C-based languages. The only difference is that we're oring and ending, in this case using actual words, as opposed to set logic that we're looking at, right? So that would be an end for the truthiness section of this exercise. And next we are going to wander over to our string section. So string section is 1, 2, 3. So I'm gonna do Python. Oh no, it's gonna be, what was it? Sorry, I just need to run a command here real quick. Update topic. It's going to be 3, right? Yep. All right, so let's switch over to our strings. So we are going to go and we're going to be using strings.py file in here. Take a look at the time, 2:28. Okay, so we're doing fine. So we're gonna take a look at strings.py here, and let's go into Replit, and let's switch over to strings, and let's run this and come back with an empty result. So we have switched over, we're running strings right now as in our debugging. So the interesting thing with strings is that Python has a rather nice flexibility with strings and string literals. And there are also some new functionality that has been introduced with Python 3.6, which is not particularly new anymore because it has been a couple of years. Python 3.9 came out this year, as I mentioned before. The deal with strings is that Python has native capability to support normal string literals. It also has native capability to support multi-line strings, and it also has this whole f-string notion, like I mentioned in Python 3.6. That is pretty cool. So let's take a look at single line string literal. Python doesn't differentiate between single quote and double quote, which means that you can include one into the other without escaping. So single line string literal, let's take an example, test equal sample line here, and we're just going to do this. We're going to do print test. So I want to separate it just to kind of give you an idea, right? So we got test sample line here. If we're going to go test equal, this isn't going to break, and we're gonna do print test. We get to put single quote because we do it in double quote. So it's not dramatically different than what I believe JavaScript is doing, but it does have that nice support for you. You also can have test. We can escape double quotes. It's helping me here with a slash. So if we do that, I need to print it, right? Print test again. So it lets us do, put a double quote, escaping it with a slash. You could ultimately put, your slash n's and slash t's to have a formatted output. So you can do test equal, this will have slash n a new line, and if you print test, you are going to end up with a new line in this string. So that's kind of kind of neat, kind of nice, but whatever, it's not that big of a deal. What else do we have? Yeah, we can let's just do a quick example of single quote test. This one is surrounded by single quotes. Let's print it, print test, and I'm going to pause a little bit just so you guys catch up. Yeah, nothing particularly magical again here. Double quotes could be included. Slash n's work. All of it is literally the same. Formatters that you would run. There are code formatters for Python. If you run a formatter, it would commonly insist on double quotes, but it's not terribly important. Either one of them works. So that being said, there isn't a simple literal for char per se. So that single quote, is still a string even if you put a single string in there. Empty string, as you would imagine, could be just declared by test empty. Is going to be declared by this, just putting empty string literal. It's gonna do print it just because test empty. Obviously it's just gonna print a new line because print puts a new line in. All right, so without further ado, let's get into the multi-line string. So ironically, you guys have been looking at the multi-line string all along, and it is at the top of this file here, right? So multi-line string starts with a triple quote, triple single quote, a triple double quote, and it ends with such as well. The reason that you see that thing on top there, by convention, this is the way you do a multi-line comment in Python. So if you want to do a multi-line comment in Python, you would add a multi-line string on top of the module, or no, actually anywhere in the code. If you're not using it as a value and you place it within your code, it is processed as a multi-line comment. There are a lot of frameworks and systems like that, and there's actually a convention of how you place comments for functions and modules, and there are plenty of various frameworks that would actually ingest those comments, multi-line comments, as you would place them alongside your code, that will allow do auto documentation and things of that nature. So it's a multi-line is actually quite broadly used throughout Python ecosystem in the context of documentation and things like that. But let's get to the actual gist of it. Let's do print. I'm just going to do a nice divider here so that we could work with multi-lines. And let's do test this. No, let's make it something short. Multi-test. And so what we would do is we would declare a triple line here and triple line here. The editor went crazy a little bit, but so now that you have here, right, all your indentations, new line started here. We can do whatever we want. Just as an example, double quote, single quote, anything, right? So let's run that. That will do nothing because we're not printing it. My apologies. So let's do print multi-test. So let's run that, and we get this output, right? So we can do a nice little output with kind of laying out however we want things to appear on the screen, with indentations, with tabs, with whatever, and it would literally ingest it as is and would put it out on the screen that way. It's, you know, it's nice, especially when you want to kind of show something in broader spec laid out the way you would like it to appear. So that's kind of the history or the story behind the multi-line. So now let's jump to f-string and f-string formatting. So I haven't shown you an old way of formatting. So there was a string format capability and ability to inject various variables and things like that. In part for a reason that f-strings are so nice that it's like not particularly worth learning the old way. We could take a look at it if you guys are interested, but let's take a look at f-strings. So the way you would put an f-string together is you would prepend a letter f prior to double quoted value or single quoted value. So let's create a couple of variables. So the key with f-string is that it allows you to inject strings. It allows you to inject variables of different types into the string without converting them or doing anything. So if we do test, keep naming everything test one, test one is going to be equal to true, test two is going to be equal to 1, 2, 3, 4, 5, test 3 is going to be equal to string something, and let's see, test 4, let's make it a float, 3, 4, 5, 6, 7, and test 5 is going to be none. Let's make that just so we see the whole gamut of things. Let's do test f string is going to be, so let's open double quote. We're going to put f prior to the double quote, and now we're gonna go and put some names. First is going to be our test one. So the way you insert a value into f string is you open and close squiggly bracket, and then you just write and a statement, rather a variable there. Second is going to be our test 2. Third is going to be our test 3. Fourth is going to be our sorry about that, not double quote, it's going to be our test 4, and obviously fifth is going to be our test 5. So the reason we are doing something like this is because when we do print test f string and we run this, we're gonna get this output, right? So let me just do, I'm just gonna copy this crazy thing, line 21 down here, so we can have a delineator before here. So I copied it on line 28. So let's run this again just to, okay, zoomed in just for effect. So again, so what we have done here, we said, we went whatever context we want to put in here, right, prior to our value. So it basically allows us to do a formatted output in a nice way, and have those values evaluated and injected there. So we're gonna get first test 1, second, and so it literally took a string representation of particular value, including value of none. So it is protected from that madness that if you output it there, it is going to take a string representation of that element and it's going to drop it in there. One of the other interesting things to know is that f string allows us to run simple inline evaluations. So if you do, let's do, we haven't done if statement, so we'll just do Boolean. So print is test2 greater than 1,000. Greater than, let's just do this, 1,000. And then we need to turn it into f string, right? Very important to put an f in the beginning, because otherwise it's just gonna print out nonsense. And we are going to say, was it test2 greater than 1,000. And let's run that. And I did something wrong. Test2 is not defined because it's test2 for some reason. Okay, so we can run evaluations. So if you want to, once we look at the if statements, you can put ternary operators here. You can do a variety of things. Whatever you can do in line, you can evaluate inside of f string. Just for kicks, I'm going to delete f and show you what happens. Literally nothing happens, right? It prints out string straight up. So like if you see output like this, where your evaluations appeared, you probably forgot an f in front of a string. Cool. So next thing, I'll let you guys finish typing real quick, and then we're doing okay on time. It's 2:42. So next thing we're going to take a look at is splitting a string, the good old split, right? So let's do CSV of 1, 2, 3, comma 2, 3, 4, comma 4, 5, 6, comma 5, 6, 7, right? So we have that little example here, and what we want is a list of the string numbers that we would end up with. So you would run a split on it, and split is a string command. So let's do that, and let's call vals equal to csv.split, and in parentheses we would indicate, so in Java I believe it's regex expression. In Python it is just a plain string. So you would, like, I would put comma here, and then I would print, we can do something like this, f, stop helping me, resulting vals are, and then vals, right? Because we can now put pretty outputs. So let's put a pretty output. So I'll let you guys catch up with this. I'm going to hit run, and so we get this, right? So we printed out a list the way it would be displayed, but what we have here, vals, is of type, let's do this, type vals, right? So we have a class list with this contents in here. So now that we have f string, we can actually produce output that is sensible and looks better. So now that we have this capability, the next thing would obviously be to join strings back in. Join is a bit weird in Python the way it plays out, but let's kind of roll with it. So let's say we got those 4 numbers. They're not quite suitable for IP address, but we'll pretend they are. And then we're gonna say, hey, we're gonna join those numbers back into, or let's not even go worry about that. Let's just say that we want that list back colon delimited, just because we want it colon delimited. So we would do a join, and here's what it would look like. First, we would indicate what we want to, a value we want to join on. So we would put double quote, and then we hit dot, then we go join, and then we would tell it what we want to join. And then you would pass a list of strings into join. So we would do that. Let's do joined list. joint string, sorry, it wouldn't be a list at that point, string. And let's just print joined string. Okay, so that's what we're doing here. So here's our output, right? So let's take a look at this again. So we're creating a variable join string equals, and then we put in double quotes or single quotes, we create a string literal that we want to be our delimiter that we join around, and then we run .join command for that string delimiter, and then we provide a list that goes in to be joined. It's very important that, again, list of vals has to be a string, not an integer, right? So let's take a look at what happens if we try to, or integer or float or whatever. So let's make a list, bad list of 1, 2, 3, 4, and then we're gonna do bed join equal to say comma, let's join it on comma dot join bed list. So if we run this, we are going to say sequence item 0 expected string instance int found, right? So this is not going to work because of the improper type. Let's see. So the one thing that hampers us, improper type. So one thing that hampers us is we don't have we haven't really played with list comprehension, so we wouldn't be able to convert it one element at a time, because you cannot convert the entire list here. You need to convert it one element at a time into a string so that you can actually print it out. So let's take a look at trailing. So stripping leading and trailing spaces. So that one, so we're looking at, commonly you get your inputs that have, leading, if you get your, some secret IDs for accounts from system nobody knows about, and, you happen to need to trim because you got some extra spaces leading or trailing. Python provides for that as any normal sane language would, and let's do test access equals to space many leading space and many trailing. Let's do end trailing. So if we do test.access strip and test score access, sorry, I want to print it. So print test.access. So let's see what comes out of that. So we have leading and trailing still remaining there clearly, right? So that's another important thing to note, is that strip does not operate on a string that is being called on. It returns a value. So we would need to do result equals, and then we would type in result. So there, it's important to know that certain functions operate on the objects while others would return a value that you would expect, but would keep the original value along. So strip does that for us. We also have lstrip and rstrip if we want to strip an individual set. So let's do, because we have kind of silly trailing there, so let's do L result. Oh no, let's do R result. R result equals to our result being like we're stripping only just the right stuff. So test access our strip, and we are going to do a little trick because we have our f string, right? So we're going to do print f and we're going to do greater than here, and then we're going to print our result here, just so that we could see where the resulting boundaries ended up being, right? So we're just going to print that value in there with those kind of boundaries. So let's run that. Some reason it's taking a little bit. Come on. All right, so we are seeing here, right? So it's stripped only the right side of the test access and not the left side. So that's kind of the example. We also have a very quick ability to drop case and raise case. So we do test case equal all upper case letters. So we're gonna do print, I'm just gonna do direct test case lower. So all uppercase letters is gonna drop test case to lower. Test other, let's make everything, these are lower case letters. So I'm kind of rushing through that, but it's relatively self-explanatory, I'm sure. Test other upper.
We should have something small.
And so this zoomed in rapidly. So these are lowercase letters that got brought into the uppercase. So we have a little bit of time. I'm going to let you guys catch up, and then I want to do a quick exercise here. I would like for you to maybe take a couple of minutes and pick any one of the, or any collection of the tools that you kind of learned above, and create me a random IP address. So I will give you a hint right out of the gate, is that if you import from random import rand int, it's single word, my bad. So if you import rand int, if you print rand int 0 to 255, it is going to give you a random number. I'm just going to run a couple of times. It's going to give you a random number between 0 and 255. I'm going to print check for understanding in here, and I'm going to give you guys a couple of minutes to, based on this information, construct a random IP address. All right, and so we can come up with, just if you want to do kind of very straightforward approach, or if you want to do a little bit more complexity, you can try a variety of different things. One of the things that I let's finish this up, and then I realized that there are a few things that are kind of important that we haven't played with in here. So let's do, I'm I'm just going to jump to a very basic solution. That's going to be quite a bit of typing, but let's go with the basic solution. Let's print, and we're going to do, let's go with f string, and all we're going to do is do rand int, and then do 0, 255. And we are going to then follow with dot, and then just copy this thing over 3 more times, put dots in between them, right? So when we put dots in between squiggly braces, those are part of the string. Anything that goes inside the squiggly braces is part of the expression. So if we were to do that and we were to run it, we are going to get a random IP address. We could also go as fancy as make a IP parts and make, I'm just literally gonna copy this thing. Let's do this. So important thing to remember, right? So we have to have this as a string. So there's a way, a string is a type, so you can convert something to string by putting str around it. That's another important thing that you can do. So you can convert it to that. So we could have actually either used f string to make it into a string, or we could just type in str around that value. Then we're just going to repeat it 4 more times just to do that. So the reason I'm doing that is because I want to use join to put this together. So if I do print for dot, using dot as a delimiter, and then do dot join on my IP parts, I can do another random IP address below. Sorry. So what that did is we made a list of strings that contain random integers, right? Because it's important for it to be in string type. And then we ran a join on it. We could also do a list comprehension building a list of 4, but we'll do that exercise when we do the lists. So another thing that's kind of important that I haven't dropped in here immediately that I want to touch on is that there is a capability to access and manipulate strings like you would lists. So first of all, let's take a look at sum of strings, right? Let me check. We are running really close. So sum of strings, test equal first space plus second. So if we do print test, it will do this, right? So we get our 2 strings concatenated. And another thing that we can do is if we have, string like this, right? We still have, so if we do another test here, we can do things that we do with lists with strings. So I believe, let me see if I'm full of it. So if we want to invert string, I think all we need to do is, of course it froze. Let's see if I'm full of it. No, so this works. So the killer with strings is that you can operate with strings like you would do with lists. And so right now what I did, if you remember in collections, we do colon, colon, and then we do step. The third one would be step in this iteration. So what I did is I grabbed test and I processed it in the inverse order. So what I did is I took the string and I inverted it and got that result. And so everything we learned with collections is possible here. So at this time it is 3 o'clock sharp. So I'm gonna finish this. Thank you very much. And this is going to be a video that I'm recording, so it's going to be published on YouTube as well. And I'll see you next time. Bye.